Hello students, welcome to Numerical Tutorials. Today we are going to learn the topic matrices. In this lecture, we are going to study the types. so, In this lecture, we are going to study first the definition. We'll study the definition and types. So we study the definition of the matrices and then types of the matrices. What is a matrices? This is an arrangement of m and n numbers, m and n numbers, okay, that m represents the row and n represents the columns, okay, and this arrangement written within a bracket is called the matrix, okay, it's called the matrix, okay, and generally represent so m cross n, okay. For better understanding, we will say r cross c. So r is number of row, c is number of column, okay. So m cross n or r cross c is known as the order of the matrix. Order of the matrix. What do you mean by order? Order itself says that the size of the matrix. It will give you the information about the element of the matrix. Okay. So generally it will define in these brackets. Okay. Or else in this bracket. Okay. So hmm, and so next, matrices are usually denoted by the capital letters. So it is usually denoted by capital letter. Capital letters. Okay, so it is A, B, comma C. Okay, you cannot denote a matrix in a small letters, but you can show the element in small letters. So what do you mean by element? Okay, so we will take a just a examples of the order. If you say the order, we will take say order 2 cross 2, 2 cross 2. So it represents R cross C. So R is number of row and C is number of column. So we represent the matrix like this. Okay. So there is two rows R1, R2, and there is two column C1 and C2. Okay. So the 2 cross 2. So the element shows like this, this, this. So 2 into 2 is 4. So matrix itself shows you that it is having a 4 element and having the position like this. Okay. So this is known as the number 1, 1, that is first row, first column. This is known as first row, second column. This is known as second row, first column, and this is known as second row, second column. Okay, this is known as the positioning. Okay, same if we will take another example. Okay, so the next examples we will say 3 cross 2. Okay, 3 cross 2. So we will represent R cross C. Okay, this is the number of row and this is the number of columns. Okay, okay, so the same elements we will draw like this. Okay, sorry, we'll draw like this. Draw like this. So 3, number of rows 1, 2, 3, columns 2. Okay, 3 twos are 6. So 3 2 2 1 2 1 2. Okay, as by the positioning, this is known as a row 1, row 2, row 3, C1, C2. So combination 1, 1, as we give the order R cross C. So the first element show the row and second shows the column. First row, second column. Second row, first column. Second row, second column. Third row, first column. Third row, second column. Okay. So by this positioning, okay, there is another definition of the matrices that in general, the element which belongs to ith row and jth column. So in general, element belongs to ith row, ith row, okay, and jth column and jth column, okay, of matrix will be denoted by A of ij, will be denoted by A of ij. Okay, so A of ij is nothing but the positioning. So I can represent A of ij as A11, A12, A21, A22, A31, A32. So this is going to know I is a coordinate of the row and J is a coordinate of the column. Okay, so say the matrix A. So I can represent the matrix A as suppose I have to show you the 3 cross 3 matrix. So I will show like that. Okay, A of 1 1, A of 1 2, A of 1 3, A of 2 1, A of 2 2, A of 2 3, A of 3 1, A of 3 2, A of 3 3. Itself, it is a 3 cross 3 matrix. Okay. In 11 and 12, okay, for the Maharashtra board, you have to study only up to the 3 cross 3 matrix. Higher matrix version will be on your higher studies. It is in the engineering or in the BSc syllabus. Okay. So, next. Hmm. So, So in general, we can write the definition of the matrices. Okay. So A is equals to, okay, A of ij, okay, order m cross n. Okay. Where, okay, I equals to 1, 2, 3 up to n and j is 1, 2, 3 up to n. Okay. This is for the presentation purpose. So you can extend the row as a 4 cross row, 5 cross 5, 6 crosses, but you have to study it in a higher division. Okay. So for this example, because this coordinate system will come in the CET exams. Okay. For this example, say A of, so giving that example, A of ij, okay. So this is 2 cross 3, say, like that. So I have already given you the example. 2, no, I will give you 3 cross 2. So 2 cross 3. So 2 cross 3, 3 2s are 6. So there would be a 6 element, 2 rows, that is called R1, R2, 3 columns, C1, C2, C3. Okay. So this will become first position 1 1. Okay. 1 2, 1 3, 2 1, 2 2, 2 3. By the definition, they are representing as A. Okay. So over here, A11, A12, A13, A22, A21, sorry, A22 and A23. This is the presentation of the matrix. So they will give you the short form or a shortcut form of this matrix and they will tell you to draw the matrix. Okay, by some conditions. Okay, so we will see the example of this afterwards in the next lecture. Okay, so this is the basic definitions of the matrices. This is known as the order of the matrices. So multiplication of the number of the orders will give you the element of the matrices, and how to position that element, how to put the element in the right position. I have taught you right now. Okay, so order of the matrix RC. RC, R for row and C number of column. RC means you have to write down the no, the given first number is number of row, and cross C, the second number will itself represent the column. Don't get confused. So in order 3 cross 3, so it will give you the number of row, this will give you the number of columns. Same 2 cross 3, this will give you number of rows, number of column. This is the basic definition of the matrices, this arrangement of the number. Okay, so next we will go for the types of the matrices. We will go by the for the types of matrices. Types of the matrices. Okay, so we will see one by one the type. Okay, first one is the row matrix. Row matrix. It is nothing but the, I will give you the example directly and I will give you the definitions. Okay. So a matrix which contains only one row is called a row matrix. For the example, say 3. You have to understand that we cannot give you the comma. It's a big mistake. Okay. So 3, 2. Okay. Next example. Okay. 2. Say next example 2, 1, 3. Okay. So first I will write down the order of this all the matrices. Okay. So 1 cross 2, 1 cross 1, 1 cross 3. So row matrix, uh, the number of row is only 1. RC, number of row is 1. RC, number of row is 1. RC, number of row is 1. So it is a row matrix. Okay. In the row matrix, we are not thinking about the columns. If the number of row is 1, it is called a row matrix. Same for this column matrix. Column matrix. Okay. For this column matrix, I will give directly the example. Same number of column is 1. So 3. So 1 cross 1. Next 2 minus 1 and 3, 2, 1. Okay. So, mm, so this is 2 cross 1, 3 cross 1. Can check. Okay. So there is 2 number of rows, 1 column, 3 number of rows, 1 column, 1 cross 1. So you can see the matrix which is of the 1 number. Okay. And having order 1 cross 1 and 1 cross 1, both are comes under the row and column matrix. So there might be a tricky question in CET about this. Okay, so there is a matrix which represent both row and column matrix. It say the element 1, 1 cross 1. Okay, so this matrix, okay, comes under both the row matrix and a column matrix with a single number. Okay, next the example is a rectangular matrix. Third one is a rectangular matrix. As itself it shows you the shape. Okay, as we are bound to study up to a 3 cross 3. Okay, so a rectangular matrix, if a matrix A of ij is called a rectangular matrix, the condition, suppose A, if A of ij, okay, this is a representations and m cross n is a order. Okay, so the condition is m if m not equal to n. Okay, the number of rows not equal to the number of columns. For this, the examples, okay, examples 2, 3, 1, 2, 1, 6. Okay. Hmm? So this use rectangular shape. Okay. Or else another one example. So we can say 2, 1, 3, 2, 1 minus 1. Same. Okay. So over here 2 cross 3. Okay. And this is 3 cross 2. So number of rows not equal to number of columns. Okay. Hmm? And the it 1 cross 3 is also comes under this topic, that is 2, 3, 1. Okay. This is a 1 cross 3 order. Okay. Next, fourth one, square matrix. Square matrix. Okay. So for A of ij, m cross n, if m is equal to n, when RC, that is number of rows equal to number of columns, is called a square matrix. Okay. So A is equals to, say, I will say 2 cross 2, or B is equals to 3 cross 3. So 1, 2, 3, 4. This is 1, 1, 1, 2, 1, 2, 3, 2, 1. Okay, so this is called a square matrix very easily. Okay, so from the square matrix, okay, it will give you rise to the, okay, to the diagonal matrix and the scalar matrix. Okay, so say diagonal matrix. So understand first the diagonal element. First I will taught you the diagonal element, then we will go by the, okay. So the definition of the diagonal elements in this, so is the matrix A and matrix B. This is considered as a diagonal. Okay, this is considered as a diagonal. Okay. Hmm. But you can say in a square. Okay. Hmm. In square, hmm, in square there are two diagonals. Also a diagonal, and this is also a diagonal. Okay, but over here we have to consider only these diagonal. Why? Because the diagonal element, the definition of the diagonal element, okay, so definition of the diagonal element, so definition of the diagonal element itself says that, okay, for diagonal element of any matrix, that is A of ij, so A of ij, m cross n, the order is say m cross n or m cross m, because the number of rows is equal to number of columns. Okay, so the condition is says that, okay, condition says that I is equals to j. I is equal to j means the position of the row and the column must be equal. Okay, or same. So over here this position will represent you 1 1, this position will represent you 2 2, this position will represent you 1 1, 2 2, 3 3. So these are considered as a diagonal element. Okay, for this for the if you consider a second as a diagonal, so this position is considered as 3 1, 2 2. Okay, sorry, this considered 1 3, first row third column, second row second column, third row first column. Okay, which is not matching. For the diagonal element, the number of row must be equal to the number of columns. Okay, so next, diagonal matrix. So itself over here you can diagonal matrix. Okay, so it's called diagonal matrix if all the non-diagonal elements are 0. Okay, so diagonal matrix, the definition, only the diagonal elements are present. Okay, so both the diagonal matrix, okay, Hmm. All its non-diagonal elements are 0. Okay, in a square matrix, in a square matrix, all the non-diagonal elements, all the non-diagonal elements are 0. Okay, for example, okay, so 2, 0, 0 minus 5, or 2, 0, 0, okay, 0, 5, 0, 0, 0, 1. Okay, so by the definition, diagonal elements are present, and all the non-diagonal elements except the diagonal elements, other elements considered as a non-diagonal elements, or non-diagonal elements are 0. Okay, so this is considered as a diagonal elements. Okay, next we will say the, or we can represent the diagonal element 1 1 1 2 2. Okay, next the scalar matrix. Sixth one is a scalar matrix. Scalar matrix. Okay, so a square matrix A of ij is called a scalar matrix if its non-diagonal elements are 0 and diagonal elements are the same. Okay, so A of ij, okay, so non-diagonal elements are 0 and diagonal elements are same. So non-diagonal elements are 0, okay, and diagonal elements are same. Okay, same. So example, okay, so example, okay, for the scalar, okay, so 3 0 0 3, okay, and for this, okay, 2 0 0 0 2 0 0 0 2. Okay, so this is your diagonal elements equal, non-diagonal elements are 0. This is called a scalar matrix. Next, identity or unit matrix. Okay, over here we can say that a scalar matrix is always a diagonal matrix, but a diagonal matrix is not necessarily a scalar matrix. Okay, so a scalar matrix always a diagonal matrix. Okay, because diagonal matrix the diagonals are present, non-diagonal elements are 0. Okay, when these diagonal elements are equal, then it comes as a scalar matrix. Okay, so this comes under the CET for the tricky question. Next is very important. This is seventh one. Very important is identity or a unit matrix. Identity or unit matrix. Identity or unit matrix. Okay, so when the diagonal elements are 1, okay, square matrix having diagonal elements are 1. Okay, Hmm. So A of ij, a square matrix, A of ij, okay, I say square matrix, so I purposely say I will write m cross m. Okay, when the order the order of the given matrix is given by the same number 2 cross 2 3 cross 3, so automatically it is a, a square matrix. Okay, a square matrix, okay, A of ij is called the identity matrix if all the non-diagonal elements are 0. So non-diagonal elements are 0, diagonal elements are 1. Diagonal elements is equal to 1. Non-diagonal elements equals to 0. Okay, it is known as a unit matrix and it is very important matrix in the inverse process. Next one. Okay, for the example 1 0 0 1. Okay, and 1 0 0 0 1 0 0 0 1. Okay, so 2 cross 2 3 cross 3 unit matrix. Okay, huh? So unit matrix is also known as a scalar matrix. Okay. Hmm. A unit matrix is also known as a scalar matrix or a diagonal matrix. Okay. Next, zero or a null matrix. Next one, zero or a null matrix. Zero or a null matrix. Okay. Every element of matrix is zero. Every element of matrix is zero. Okay. So example 50 0 0 0. Okay. Next is triangular matrix. So we will see the triangular matrix afterwards. Okay. So first over here, next we will see the determinant of the matrix. Okay. Next, ninth one, determinant of the matrix. Determinant of the matrix. Okay. So say A is equals to 4, 6, 3, 5. Okay. So then determinant of the matrix is, we say the determinant sign 4, 6, 3, 5, and then we find the determinant as cross multiply. So this is a 4 into 5 minus 6 into 3. So 20 minus 80. So the answer is 2. So determinant of the matrix means valuation of the matrix. So determinant of the matrix is 2. So how to find out the matrix determinant of the 2 cross 2 matrix? Okay. So we will represent in this is a determinant sign. Okay. And we will represent in the determinant manner. Okay. So first row 4 6, second row 3 5, and then we will start the solution is 4 into 5, okay, minus 3 into 6. The answer is 2. Clear? And in next lecture, we will see how to find out the determinant of the 3 cross 3 matrix. Okay. Next one, 10th one. Next one is a, say, non-singular matrix. Non-singular matrix. Okay. So non-singular matrix, if a square matrix A, so hmm, hmm, a square matrix A is called non-singular if. Okay, non-singular if condition क्या है? If magnitude of A is equals to not equals to 0. Okay, for example 2 minus 3, 4, 5. Okay. Say A is equals to B is equals to the determinant of the B is 2 minus 3, 5 is equal to 5 to the 5 into 2 minus 3 into 4, 10 minus 12. So 10 plus 12, that is equal to 22, that is not equals to 0. Okay, so this is known as a non-singular matrix. As of the same 11th singular matrix if magnitude of A is equals to 0. Okay, singular matrix. So this we uh, uh, understand this condition, singular non-singular matrix, carefully, because you have to use this as a first step in the finding the square inverse of the matrix. Okay, so for the singular matrix equal to 0, so let's say example A is equals to 2142. So determinant of A is equals to 2142. So 2142 is equal to 2 2s are 4 minus 4 is equal to 0. Okay, which is equals to 0. Okay, so it is known as a singular matrix. So A is a singular matrix. Okay, next. So next we will go for the triangular matrices. Triangular matrices. It consists of the two types. Okay, A, upper triangular matrix, and second one is a lower triangular. A square matrix A of ij is called the upper triangular matrix. So square matrix A of ij, okay, is called the upper triangular matrix if every element below the diagonal is 0. Okay, if every element below the diagonal is 0. Okay, so hmm, so that is A of ij is equal to 0. Okay, when I is greater than j. Okay, example. Okay, so I will show you the example. Okay, so 2 3 0 minus 4. Okay, 3 1 2 0. Okay, 2 1 0 0 7. So in upper triangular matrix, okay, find out the this triangle. Okay, this one element. Okay, or in 3 cross 3, this is the triangle. I'm drawing the triangle, zeroth wala triangle. Okay, in upper triangular matrix you can see the triangle below the diagonal. Okay, zero wala triangle. In lower triangular matrix you will find out same triangle on the upper side. Okay, B, lower triangular matrix. Okay, for the lower triangular matrix, hmm, so a square matrix, say A of A is equals to A of ij, okay, is called a low triangular matrix if every element above the diagonal element is 0. Okay, every element above the diagonal is 0. Okay, so the condition itself say that A of ij is equal to 0 when I is less than j. Okay, over here I is greater than this, so I, this is 2 1. Okay, so 2 is greater than 1. This is 3 2, 3 is greater than 2. 3 1, 3 is greater than 1. Okay, so here I is less than j. Okay, so examples: 3 0 2 5. Okay, over here. Okay. Hmm, hmm. So 12 0 0 8 4 0 6 7 6. Okay, same. So we will find out the triangle. Okay. Hmm. So this, okay, over here, this is a triangle. Okay, you have to concentrate on this triangle only. If it is somehow somewhere, fortunately or unfortunately, instead of 4 it is comes as a 0, as a 6, don't get confused. We have to find out by only these three element triangles. Okay, next, number 12 and then 13th. Okay, there are last two remaining. Okay, as we known as a hmm, symmetric matrix and skew symmetric matrix. So symmetric matrix. Okay, so before that, we will study the transpose of the matrix. Okay, before that, we will study first one, transpose of the matrix, and then we'll go by the symmetric and skew symmetry. It is very easy. Okay. Hmm. Next, a transpose of a matrix. Transpose of a matrix. Okay. So, what's the definition of transpose is if A is equals to 2, 1, 3, 2. Okay. So, transpose itself denoted as A dash or A, say T, transpose. Okay. So, 2 cross 2. So, the transpose of matrix itself says that we interchange the rows and column. Okay. So, whatever is the row, write it as a column. So, the order is again 2 cross 2. So, this is 2, 1, 3, 2. Okay. For the better understanding, we will take the another example of the example rather than square matrix. Okay, so say A is equals to, okay, 2 minus 3 1 4 5 6. So this with the order 2 cross 3. So the transpose A transpose itself will give you the order of 3 cross 2. Okay, so you have to 3 row 2 column. Okay, so you have to write down the rows as a column. So 2 column, 2 minus 3 1 4 5 6. So this is known as a transpose of a matrix. And over here, so A dash is the okay. Hmm, hmm, okay. So if you consider a square matrix, okay, so you can easily check for the square matrix determinant of A, the value of the determinant of A is equal to determinant of the A transpose for the square matrix. Okay, so for square matrix, okay, so determinant of A is equal to the determinant of A transpose. Okay, and last one is A transpose of transpose is equals to A. This you can check for every matrix. Okay, for every matrix. For every matrix. Okay, last number is 14 and 15. This will be the end of the lecture. Symmetric matrix, Q symmetric matrix. Symmetric matrix. Okay, next skew symmetric matrix. So symmetric matrix. Okay. Hmm, hmm, hmm. If a square matrix A is equals to A of ij, okay, is called symmetric matrix if A is equals to A dash. Okay, it's known as A is equals to the A dash. Okay, so example. Hmm, hmm. That is A of ij is equals to A of ji. Okay, example. You can see the example. Okay, 2, 3, 3 minus 1. Okay, hmm. Then say this is A. Okay, and the A dash itself is 2, 3, 3 minus 1. Okay, the symmetric example. Okay, next 15th skew symmetric. Q symmetric matrix. Okay, so skew symmetric matrix A is equal to A of ij. A is equals to A of ij. Okay, it's called a skew symmetric matrix if A is equals to minus of A dash of A of ij, that is A of ij is equals to minus of A of ji. Okay, for all I and j. Okay, so examples 0 minus 4, 4, 0. Okay, next over here 0, 1, 2, minus 1, 0, minus 3, minus 2, 3, 0. Okay, and there is a conditions. The diagonal element of the skew symmetric is always 0. Okay, the diagonal elements are always 0 for the skew symmetric. So over here we can say, you can see, you also check out the example of the symmetric matrix in your notebook or your notes or whatever it is. Okay, so I'm giving you the simple trick. Okay, over here we will put as a mirror. Okay, if we put a mirror over here, so same number will represent over here. So it is called a symmetric matrix. Okay, in skew symmetric, the negative number represent. Okay, in the mirror image, this is minus 1, 1, minus 2, 2, 3, minus 1. Same. 4 to minus 4. Okay, so this is the example of the skew symmetric matrix. So in this session today we study the definition and the types of the matrices. In next section we will see how to build up the matrices: addition, subtraction, and multiplication. We cannot do the division in the matrices as that of the derivatives. We have four rules. Over here we also we have only three rules: addition, subtraction, over here so scalar multiple, and then multiplication. We don't have division. Okay, so that's it, students. Okay. Hmm? Take care. Hmm? Please do like, share, and subscribe. Okay, thank you so much.